Good morning, good afternoon, or good evening, depending on when you're watching this video. Now, today's lesson is a chain rule, and we have actually used this in the last lesson, on Friday's lesson. We looked on Friday at differentiating x plus 1 to the power of 6, and you know that it would be 6 times x plus 1 to the power of 5. What is really happening there is laid out on the screen. d by dx of x plus 6, there are two functions there. You studied composition of functions. This is a composition of functions. It's x plus 1, the function first carried out first, x plus 1, and then the next one, x to the power of 6. You're raising it to the power of 6. So to use the chain rule here, you would differentiate each function in turn. Differentiate the outer function, the second function, multiply by the power and reduce the power by 1. So 6 times x plus 1 to the power of 5, and then times differentiate what's inside the bracket. So when you differentiate x plus 1, differentiate x and you get 1, differentiate x and you get 0, so you're multiplying by 1. That's why you got that result. Now, the next thing we did in Friday's lesson was to differentiate 3x plus 5 to the power of 4. And you notice that was not just 4 times 3x plus 5 to the power of 3, that it was more complicated. And what in fact is happening is you're using the chain rule, you're differentiating the outer function, multiply by the power and reduce the power by 1. So 4 times whatever you have inside the bracket to the power of 3, and then you differentiate what's inside the bracket. Differentiate 3x plus 5, differentiate 3x and you get 3, differentiate 5 and you get 0. So it was 12 times 3x plus 5, and that's why that's happening. 12 times 3x plus 5 to the power of 3. Now we're going to extend this. On Friday, we only dealt with linear functions, powers of 1. Now we're extending this to anything that's inside that bracket. So the chain rule basically is d by dx of whatever you have inside that bracket, multiply by the power and reduce the power by 1 times the derivative of whatever you have inside that bracket. Let's do some examples then. Differentiating x squared plus 3x to the power of 3, we would multiply by the power and reduce the power by 1. So 3 times whatever we have inside the bracket to the power of 2. And what we have inside the bracket is x squared plus 3x. Now we're going to turn our attention to differentiating what we have inside the bracket. And that is x squared plus 3x. Now we've differentiated the first part, so I'm just going to write that out again. 3 times x squared plus 3x to the power of 2. Times differentiating what we have inside the bracket, 2x plus 3. Now I'm going to multiply that 3 times 2x plus 3, 6x plus 9. So 6x plus 9 times x squared plus 3x to the power of 2. And that's that finished. So let's do a second example. Now in this second example, we're not ready just to go straight into differentiating. We have to prepare it for differentiating first. So we would write it as x squared plus 3x to the power of a third. And it's exactly the same. Two functions here. We're going to differentiate the outer function, multiply by the power, so that would be 1/3 x squared plus 3x, reduce the power by 1, negative 2/3, and then we're going to turn our attention to differentiating what we have inside the bracket, x squared plus 3x. So that would be 1/3 times x squared plus 3x to the negative 2/3 times 2x plus 3. Now let's write in the final line, that is 2x squared plus 3x to the negative 2/3. So that's going to be 2x plus 3 all over 3 times x squared plus 3x to the power of 2/3. And that finishes that. Okay, let's look at using the chain rule for trig functions. In number 1, if we were asked to differentiate cos squared x, now we know that cos x, we could put inside the brackets cos x squared, and that's cos x times cos x, is equal to cos squared x. So if we're going to use the chain rule, we would have to write this as y equals cos x all squared. Now that's exactly the same as we've been doing. So if we were going to differentiate dy by dx, there are two functions here. We would differentiate the outer function 2 times whatever you have inside the bracket to the power of 1. And then we would differentiate what we have inside the bracket, so d by dx of cos x. Now you know that differentiating cos x is negative sine x, but you're actually given this in the table of standard derivatives in your formula sheet. So differentiating cos ax is negative a sine ax. A here we could think of as 1. So We have over here 2 cos x, because cos x to the power of 1 is just 2 cos x. Differentiate cos x and you get negative sine x. Now that's negative 1 sine x, so that is equal to negative 2 sine x cos x. And that's us finished that one. Okay, let's do a second example. If we were asked to differentiate y equals sine 4x, then remember we're going to use the chain rule, so y equals sine, and I'm going to put the 4x inside the bracket here. Now in this type of example, what you would do is differentiate sine. So you are going to differentiate the sine function first, so dy by dx, which is the second function or the outer function. So sine 4x, differentiate sine, and you get cosine. So that's cos 4x. And then we turn our attention to what's inside the bracket, d by dx of 4x. So that would be cos 4x. Differentiate 4x and you get 4. So that's equal to 4 cos 4x. Now you're actually given that in that table of standard table of derivatives up here, where you have cos, you're differentiating sine 4x, there's sine ax, and it tells you that differentiate sine, you get cos. So differentiate sine ax and you get a cos ax. Differentiating sine 4x and you get 4 cos 4x. So that is given in your table of derivatives, but that's showing you how to do it with the chain rule. Let's do a third example. Let's see if we had f of x is equal to sine 2x plus 1. Same story, we're going to differentiate the outer function. The inside function is 2x plus 1, outer function sine 2x plus 1. So we're going to start from the outside, differentiate sine, and we get cos. So it's cos 2x plus 1. And then we turn our attention to differentiating what's inside the bracket, 2x plus 1. So that would be cos 2x plus 1 times, and if we differentiate what's inside the bracket, that would just give us differentiate 2x and we get 2, differentiate 1 and we get 0. So that's 2 cos 2x plus 1. Okay, let's do a third example, a fourth example rather. So if we were given y equals 1 minus sine x squared, then again, chain rule, so we're going to differentiate the outer function, and that would be 2 times 1 minus sine x to the power of 1, and then we would differentiate what was inside the bracket. Now inside the bracket we have 1 minus sine x, so that is equal to 2 times 1 minus sine x times differentiate what's inside the bracket, differentiate 1 and we get 0, differentiate sine x and we get cos x, so that's minus cos x. So that is equal to minus 2 cos x times 1 minus sine x. Let's do one more example, a fifth and last example. Let's do number 5. If we were asked to differentiate y equals 2 over sine x, that's not ready to be differentiated, so we can't launch into differentiating. We would have to write that as 2 times sine x to the negative 1. Now we're ready to differentiate, so dy by dx is equal to, now 2 is just a constant, so we're differentiating the sine x to the negative 1, multiply by the power, and reduce the power by 1. And then let's turn our attention to what's inside the bracket, differentiate sine x. So that would be 2 times negative 1 times sine x to the minus 2, differentiate sine x and we get cos x. So we have then negative 2 cos x would be on the top line, all over, now this is sine x to the minus 2, so that would be sine x to the minus 2 squared, all over sine squared x. Now that's examples then using the chain rule for differentiating trig functions. Now I want you to note that this is not how it's done in the textbook. I want you to do it like this. It's a much more mathematical way, So this is a method I want you to use. So don't look at the textbook introduction, use these. Okay, thank you.